Good morning, class 10. Today we'll be doing chapter 6, factorization. As you all know that we have completed this chapter that is on mensuration and different kinds of solids. Now we are going to move back to our books and move back in our books, and we'll be doing chapter number 6 now. What is chapter number 6 based on? Okay. So basically factorization. You might have heard this word before as well. Factorization. We have done this chapter in class 9 and also in class 8, also in class 7. But what we are going to do in this exercise is going to be totally different from what we have already done, and we'll try to factorize the terms. But today we'll learn how to factorize the polynomials. Okay, how to factorize the polynomials. But what are polynomials? What is a polynomial? An expression or an expression that can be written in the form of okay. That can be written in this form is called a polynomial. This is called a polynomial. Now you might be thinking, sir, we are getting confused. Please tell us the simplest thing. What does a polynomial mean? I'll tell you that polynomial is basically, for example, 3x square or 3x4, 3 to the power 3x to the power 4 plus or we can say minus x to the power 3 plus 9 x to the power 2 plus 5x plus 7. Okay, so what do I have over here? This is a polynomial. Okay, the polynomial, the x power can go as much as it can. Okay, it can go to x to the power 100 or x to the power 1000, and that will be called a polynomial. So over here, if you compare this and this is a naught and this is a1. So what is a1 right now? I have nothing over here in place of a1. So what have I written over here? 1. When there is nothing, it means there is 1. So basically this a, all the a's are the coefficient of x. They are called coefficient of x. You have heard about the word coefficient. Coefficient means if I hide, so if I ask you what is the coefficient of x square? X square coefficient is 9. If I hide x square, what is the coefficient? What else is lying with x square right now? That is 9. So what is the coefficient of x square? X square coefficient is 9. What is the coefficient of x? 5. What is the coefficient of x to the power 4? 3. Okay, so these are the coefficients a, a1, a2, a, n minus 1, a, n. These are called coefficient. But the last term is called constant term. What is this called? Constant term. Why is this called constant term? This is called constant term because that is never going to change. This can change. Why can this change? For example, if x is 7, then 5 7s are 35. It can change. For example, x, in the next question they gave me the value of x, that is 2. So this will become 10. 5 2s are 10. But this will stay constant. It is never changing. So that's why we call it a constant term. The last term is called the constant term in which there is no x taking place. That is called constant term. Okay, so this is called polynomial. Okay, I'll be telling you what are the other types of polynomial. The first one is linear polynomial. So this is linear polynomial. This is called linear polynomial. Why this is called linear polynomial? Because the highest power that is over here is 1, or the highest degree is called 1. If I would have kept like this, or equals to 5, then I would have called linear equation. We have done this topic, linear equation. But this is not equation right now what I am talking about. I am talking about linear polynomial. Okay, why do I say linear? Because the highest power of x that x is carrying is 1. So that's why I call linear polynomial. Okay, second one. For the second one, I have 5x square plus 2x plus minus 5. What is the highest power you guys see over here? The highest power I see over here is 2. So this is called quadratic polynomial. Okay, quadratic polynomial. If I would have kept equals to 7, then it would be quadratic equation because equal sign is coming. But right now we are not talking about equation, we are talking about polynomials. So this is quadratic polynomial. Why? Because the highest power is 2. Whenever the highest power is 2, we call it a quadratic polynomial. Okay? If the highest power is 3, we call it a cubic polynomial. You guys can have a look on page number 96. You will see, for example, on the same page 96, you will see cubic polynomial, biquadratic polynomial. If the highest power is 4, then we say biquadratic polynomial. Okay, if the highest power is 4. If it is more than 4, okay, we call it a polynomial. Okay, you don't have to. Agar 4 se zyada hai, 5 hai, 10 hai, 100 hai, then we call simply it is a polynomial, nothing else. Okay, but now you know if there's the highest power is 1, then I call a linear polynomial. If the highest power is 2, then I call it a quadratic polynomial. If the highest power is 3, I call it a cubic polynomial. Okay, last one. For example, I have written nothing, just 7 or any other number. Is this a polynomial? Yes, this is a polynomial. Okay, if you see in your books on the same page, page number 90, the last example that is given, page number 96, this is called constant polynomial. Because with this, there is x, but x has how much? What is the power of x? 0. So whenever there is something and which has a power 0, then I have the value 1. So it means this is also polynomial. Simple numbers are also called polynomial, but they are called constant polynomial. What are they called? Constant polynomials. I hope you guys are getting it. Okay. So a number that has no x, only a number, that is also called a polynomial. Simple number. That is called a constant number. Okay. Okay. Now today we will be learning some basic things, and in that basic thing is going to come. Okay, we will be learning remainder theorem. There are so many other things in this, but we will be learning tomorrow on the same topic. But today we just want to have a look at remainder theorem. Okay, many of you, I would like to explain you or take you guys back to class 2nd or class 3rd when you started dividing. You started dividing and you used to get a remainder down over here. For example, I'll give you an example. So 19 divided by 6. 6 3s are 18. Right? And what is left? 1 is left. So this was called the remainder. Isn't it? This was called the remainder. Even for this, we'll be finding out remainder. For example, let's say this is a polynomial, right? This is a quadratic polynomial. In quadratic polynomial, what we need to focus is this, that polynomials can be written like this. They can be named like this, fx, or you can also name it gx, hx. Okay? You can name this. So right now I have a polynomial whose name is fx. And I have another polynomial whose name is gx. And what is a polynomial? Okay, so I have 2 polynomials. Now my question would be, in the exercise, my question would be, when you divide fx by gx, what is the remainder that will be coming? Now most of you know that in class 8 we did learn this dividing x plus 3 divided by 2x square minus 7x minus 1. We did learn, right? You all remember. Did you guys learn? Okay. Just try to recall your memory, and you'll understand that we did learn how to divide the algebraic terms in the algebraic portion. Okay, so we did learn this. But the question will be without dividing, without doing all this. Tell when this is divided by that, or that is being inside and this is coming as a divisor. What is the remainder? What is the remainder that is going to be left? Without dividing, explain. So I'm going to tell you the shortcut form of doing this. Okay. So when I divide this by this, how to divide it? I'll say let's take x equals to -3. Okay, why? I just kept an equal sign over here and I shifted 3 over there. Now in place of x, wherever I find x in this, I'll put -3. Okay. So what I am doing, in place of x, I am putting -3 equals to 2 -3 whole square minus 7 into 3. Sorry, -3 minus 1. So 3 times, that is 9, and minus also 2 times plus 9 2s are 18. I got 18 minus plus 7 3s are 21 minus 1. Okay, so 18 plus 21, how much it will be? So 9 and 3, 39 minus 1, that is 38. So what is my remainder that is coming when I am putting x equals to -3? When I am keeping x equals to -3, or if I am dividing this by this, what is my remainder coming? 38. My remainder is going to end up coming 38. You didn't divide, you didn't do anything. You just kept whatever needed to be outside and be divided. So this was inside like this, 2x square minus 7x minus 1, and this was outside. So when you divide this by this, then the remainder that is going to come at the end is going to be 38. You don't have to divide. So this is how it should be. Okay, the question will be like that. You can look the very first example. I have taken the example, the number or this polynomial from example number 1. Go ahead and look in example number 1. Okay, stop the video and go ahead and look. So this is how you have find remainder. Okay, without solving it. So the very first thing that we are going to learn today is finding out remainder without dividing, without actually dividing. Okay. So even if you divide this by this, what will be getting if you divide? So you can see, you need to cancel this out. So x into 2x will be 2x, and then 3 into 2x will be 6x, and then I will solve it. I will get minus 13x, and how to make it minus 13? Multiply by 13. X into minus 13 will be minus 13x, and then plus minus minus and minus 39. Now change the sign. Plus, this is going to get cancelled out, minus plus is minus, and then what is the value I will be getting? 38. So what is the remainder I am getting? 38, but without dividing it you are getting 38. Okay, so whatever needs to be outside and is dividing this term, then you need to just take the value of x from here and keep it in the bigger equation or the bigger polynomial. Okay, we'll do one more example. Okay, let's see example number 4 from your books. Okay, let's see example number 4. What does example number 4 says? So example number 4 says, please read with me. Example number 4, page number 100. It says when x cube and plus 3x square, x cube plus 3x square minus kx plus 4 is divided by x minus 2. The remainder is k. What is the remainder? They have already given me the answer. Remainder equals to k. Find the value of the constant k. So they said find the value of constant k. I have to find this. This is a constant. Obviously, this is a constant because the number takes place with x. So this is a constant. This is a number. Now you know I can name this. This can be fx and this can be gx. right? Now I'll put which value in this equation. What is the value that I'll be keeping in this equation? You guys tell me. Okay, so I'll be keeping which equation? This one. So x equals to, when minus 2 goes over there, x equals to 2. I'll be keeping x equals to 2. Okay, so when I'm keeping x equals to 2, then 2 per cube plus 3 2 per square minus k into 2 plus 4. Isn't it? So I just kept in place of x 2 I kept. Okay, in here also I'm keeping 2. Okay, I'll get 8 from here plus 4 3 is 12 minus 2k plus 4. Isn't it? And then they have told me the remainder that I'm gonna get. What is the remainder I'll be getting? K. Remainder that we'll be getting already is k. I'm just writing my answer down. Even here I can also write k. The remainder that I'll be getting is k. That is the remainder that I should get, and they have given it. I don't have to prove it कि हाँ भी k लेके आना है. No. The remainder will be k. So I'm just keeping it over there. So 8 plus 12 20. 20 plus 4 24. 24 minus 2k equals to k. But I have to find the value of k. Are you guys understanding? They didn't ask to prove it. If the remainder is k, here also k should come. No. The question was, this is a polynomial. That is a polynomial. This polynomial needs to be divided by this polynomial. The remainder is k. Then we said, okay, if remainder is k, then we'll try putting the value of k. Okay, or we will try finding the value of k by putting the value of x equals to 2. Okay, so I was finding, so this is what I got the remainder. I can't solve this further, but I already know the answer of the remainder k. So what I'll be doing, 24 equals to k plus 2k. Now 2k shifted over there. What did I got? 3k. 24. Now 24 upon 3 equals to k. 3, 8 are 24. So 8 equals to k. So what is the value of k? 8. So what can I keep over here? K. Is it okay? I hope that's helpful for you guys. We'll do one more question. Okay. We'll see example number 6. Okay. From page number 100. So example number 6 says there are two polynomials. This is one polynomial, this is another polynomial. And when both of them get divided by only one polynomial, that is this. What they are trying to tell you, that if that polynomial is dividing this polynomial, and that polynomial is dividing this polynomial. So x minus 2 and x minus 2 is dividing this polynomial, ax cubed minus 7x plus 7x minus 2, and the same polynomial is dividing x cubed minus 2ax square plus 8x minus 8. If both the polynomial is being divided by the same polynomial, the remainder is coming same. Whatever the remainder is coming over here, then the same remainder is coming over there. They are trying to say. Okay? So let's find the remainder for the first one. And then find the remainder for the second one, and then we'll keep them equal. So if I have to find the remainder for this, what is the value of x I will have to put? You can see over there, I am dividing by that. So what is the value I will be keeping? 2. Okay, so a 2 cube minus 7 2 per square plus 7 into 2 minus 2. And what is the value I will be keeping over here? The value that I will be keeping over here also is 2. Okay, let's solve this first. Equals to 8a. 28, okay, plus 14 minus 2. There are some like terms, we let's subtract the like terms. So 28 plus 14, that would give me 14 minus 14 and minus 2 minus 16, 8a minus 16. Okay, let's find for this. So this is also being divided by this. So what is the value I will be putting for x? That is 2. 2 per cube minus 2a into 2 per square plus 8 into 2 minus 8 equals to 8 minus 4 4 to the 8, 8a plus 16 minus 8. So I'll be getting, so this is the remainder for this one, and what is the remainder for this one is this, and this can get cancelled out, so minus 8a plus 16. So both the remainders are same. Okay, so what I'll be doing, I'll be keeping both the remainders equal. So 8a minus 16 equals to minus 8a plus 16. Okay, so 8a and 8a can go on one side, so minus 8a will come on this side. A will be coming 2. And why did I keep both of them equal? Because they said the remainder will be equal. Whether over here 7a plus 19 would have been coming, then also I would have kept them equal. Why? Because they told me that the remainders are coming equal, so we need to keep it equal at the end. Is that okay? So that's how remainder theorem works. Whatever needs to be divided, you'll be taking them. Okay, x equals 2 or something like that. Even if you're dividing by this 2x minus 3, then what will you be taking? You'll be taking x equals to minus 3 is going to go over there and 2 will come down. So you'll be putting what in place of x? Minus 3 upon 2. Okay, every time you do, keep something, the value of x, in order to find the remainder. So that's why this is called remainder theorem, because we find theorem. We find remainder using this theorem. Okay, good job.